Okay, I'm going to get started. And I just wanted to kind of say something before we get started, which is kind of just to kind of give a shout out. There's probably some more important things going on than the topics that I'm covering in this talk, and that's like stuff like Black Lives Matter movement. And I was kind of like wondering what kind of things, like how we can kind of, what we can do about this. And I think it's basically acknowledging this on a personal, community, and professional level is like really important. And I found this site, which is blacklivesmatter.cards.co, and it's got some really great resources on it for kind of like getting some knowledge about the issues. And in particular, if you scroll down on the site, there's a UK specific page which gives a reading list, and yeah, there's some really great content in this. So if you take like one thing away from this talk, visit the site, do some reading, and kind of like yeah, learn about some of these issues and stuff. Yeah, so, oh, sorry, I'm just gonna tweak this a little bit. Yeah, perfect. So hey, yeah, I'm Ben Foxall. It's really nice to be here. This is actually the first ever remote meetup that I've spoken at, which is kind of cool. Though I do spend a lot of my day on Zoom these days, so I'm feeling quite natural right now, you know. Like, so it's like just being at work. And it's really nice to be here with Mike. Hey, Mike, how's it going? Yeah, so I work with Mike, and I really enjoy that. And so before lockdown, we used to see each other every day and chat. And I guess like even now that we are locked down, we still do that over Zoom now, which is kind of cool. So maybe not much has changed. But yeah, anyway, I've got a lot. I've learned a lot from Mike, and I've really enjoyed working with him. And I'm really happy that he's able to kind of share the stuff he's been working on and testing with everyone else. So yeah, I think you should be looking forward to that. We both work at a company called Oxbotica. We write software to help cars drive themselves. So this is one of our cars in the garage. And we've got this idea of universal autonomy. So that is that our software, we should be able to kind of take it from one car into another and an entirely different situation, and it should still operate. So a really good example of this was last summer. 5 of our cars were running in autonomy around the busy streets in London. And so they're all operating in this fleet. And a few days later, using exact same software, we were able to use that in a completely different environment in this field with sheep in it, different sensors, different kind of tasks. So yeah, we've kind of got our software spans all these kind of use cases. So you might be wondering like what the web team does here, because Mike and I are on a web team and we're like into JavaScript and stuff. And yeah, we don't actually drive the cars with JavaScript, but it has been suggested recently, which is kind of cool. Basically, we've got like some hefty autonomous stuff that actually runs on the vehicle, but we need a lot of stuff around that, and we use the web for some of that tooling. So you can see we've got like fleet management tools, map management, and dealing with some of the data that we get back from the cars. So yeah, we've got a lot of different tasks that we work on in the web. If you're interested in kind of like what we do and be kind of getting in contact, give me or Mike a shout and we'll kind of give you more information. My face is on the careers page, so I like to think of myself as the face of Oxbotica, but that's not actually an official title, but it is now that I've said that, I guess. Yeah, I am officially the face of Oxbotica. You heard it here. So yeah, Mike and I were talking about, so we gave similar talks a few months ago, and we realized there was this really nice kind of synergy between the topics we're talking about. And so we kind of got chatting and thought it'd be really cool to be able to kind of give the two talks together. And Adam, like, thanks a lot for kind of letting us come and give them here. So yeah, we're basically going to be talking about building and testing a new web, and we're kind of going to try and follow some of the similar kind of rhythms and styles of our talks, which should become apparent hopefully. Cool. So what I'm going to do is, I'm going to be talking about interfaces like using gRPC and protocol buffers in particular, and then peer-to-peer stuff. But the way I'm going to talk about this is about a series of ways that we can challenge the normal way that we interact, well, that we build websites. So what I'm going to go through is a series of received wisdoms So kind of things that we have assumed to be the correct way of doing stuff, and then suggesting an alternative and investigating that alternative more. Cool. So yeah, this will make more sense once we're into it. Received wisdom number 1. So there's this idea that we should use JSON for data. So when you're kind of requesting data, like, it's pretty much our kind of de facto standard for structuring data. And just to kind of like give a bit of an outline of this, we've got this really useful web page here. And if we clicked on this kind of view comments button, we'd expect to kind of make a request somewhere and populate it with some comments. So what we do is our web page makes a request to a web server, pulls that content back and populates that page. And this is what that structure might look like. So you make a HTTP request for get posts 1b982/comments, and then you get this content back. And that content, the structure of that is JSON, right? Like, and JSON the term JSON was coined in 2001 by Douglas Crockford and team, I think. And this is what it looks like. So we're at JavaScript Meetup, so I'm sure a lot of us will be familiar with this. So you basically got these square brackets, which signify an array, curly brackets, which signify this kind of object thing. We've got these strings with quotey things, and then we've got a number without the quotes, and then we got some true or false values. And that's what JSON is, which is cool. What's really cool about JSON is it's actually JavaScript, like, so it's JavaScript object notation. So we can kind of, we can just basically like plonk that straight into our scripts and we can do stuff with it. So it's kind of cool. And the nice thing about that is that because JSON is pretty much JavaScript, if you squint your eyes a bit, you can imagine it working all the way back to Netscape Navigator 2.02, which is 1995. So basically it was defined in 2001, but it was kind of available way before that. So it's kind of like of the web, which is cool. And nowadays it's really super baked into our platform. Like we can convert things to and from JSON very efficiently using kind of web APIs. But there are alternatives to this. So one alternative that I was going to talk about today is protocol buffers. Has anyone here heard of protocol buffers? Maybe I have. But yeah, Adam's raising his hand. Dan's raising his hand. Excellent. Cool. Some people have. So for those of you who haven't, or those people who have, for everyone, this is what a protocol buffer is. So basically, what you have is you've got this proto file, and that defines a message. So we've defined a message of a type horse, and that's got a string here. And we basically define properties of this in a kind of separate file. And then using that file, we can generate some stubs. So we basically run this proto-C, which is proto compiler, point at our proto file, and then it outputs some JavaScript. And we can then import that JavaScript into our projects. So we can basically, we get this handy object with those properties and we can set them on it. And yeah, we can kind of play around with the data of it. And then we can call this serialized binary function. And what that does is it outputs that content in a kind of optimized buffer form. The output is different. So in JSON, we might have a kind of string that contains this stuff, whereas protocol buffer would just be kind of raw bytes that are easy to map to and from that object. I really like protocol buffers. Like I'm a big fan. I think one of the things I like is that it's much harder to make a mistake because I'll show you in a second. The way you have those objects kind of prevents you from making a certain class of mistake. It's really efficient on the wire. Like if you care about that kind of stuff, it compresses down a lot more. And we've got this type safety. Like, so unlike JSON, if you get something and you presume it's a number, you can't necessarily be sure if that JSON came from somewhere else. Whereas if you decoded a protocol buffer, you totally know where it's at, and you know, and that is particularly awesome in more complex objects. So that, yeah, it's kind of good. And I'll explain this a bit more as well as like, as well as that type safety in JavaScript, we've got type safety across many different languages. So when you've got a number and that's in Python, and you've created a protocol buffer, you know when you've taken that object across to your new language, you'll still know that it's still a number, like you've got that kind of safety. So these are mistakes. If you make a spelling mistake in JSON, then you've got to kind of trace down where that is and like where it was generated and where it's causing a problem, and it involves a lot of manual debugging. Whereas with protocol buffers, you spelt the method name wrong. So if you're using, so hopefully that's like a compile time error. But even if you're using something like TypeScript, it will be a kind of, as you're kind of like typing it, you'll know that you've made an error. So it makes it a lot harder to make these kind of class mistakes, which is cool. As I said before, binary data, pretty cool. In our object, we had these tags in them. So these numbers, and they relate to points within that binary object. So basically, if you have that proto file, you can then decode that binary object, pulling out those properties yourself. And something that's nice here is like we've not actually have to store the property names. We've just stored the numbers, or we just know where to expect them in our receiving end. And JSON numbers are stored as strings, whereas protocol buffers are using variant encoding. I've got this little kind of demo script here, which shows how that works. So basically, as I make this number bigger, you can see the kind of difference between those two encodings. So I'll share that later if anyone wants to use it. Yeah, this is kind of weird one. So in JSON, true, which is like the most kind of fundamental basic thing, is stored as 4 characters, which is kind of like a bit odd. So yeah, so it's a bit more efficient in protocol buffers. And yeah, you can also have different types. You can store binary objects. If you've ever done like base64 encoding within JSON, then you'll know why this is kind of cool. Yeah. And as I said before, portability. So as well as generating JavaScript, you can generate all these other languages, generate those stubs, and then you've got this kind of like interoperability between those languages using protocol buffers. Right, we have got some demos. So npm run demo 1. Right, so I was just going to show a tiny little demo of doing this encoding. So we've got that protocol buffer proto file, which defines this type of horse. And so I'm going to call this horse Franklin. This horse likes carrots, and this horse is 18.1 hands high. And so those binary objects, I can put in an image here, and we can see that's been output here. So this buffer has been formatted as string, so I can paste it elsewhere. And then when you paste it down here, we're able to kind of pick up that data in a completely different context and decode it. And you can see that image down here is being decoded too. If we change this slightly, it's no longer a valid protocol buffer. So it now no longer works, which is kind of what you want, right? That's what I want. Cool. Right, so second received wisdom is that we should be using REST for web interfaces, right? Like, so back to this example where I've made a GET request for these comments. This whole kind of structure is REST. And REST stands for Representational State Transfer, which was coined in the year 2000, so a year before JSON. Wow. So yeah, and this is what it looks like. You basically got these kind of, this URL structure, which identifies a particular resource, and that can be nested. So the idea that this refers to posts with an ID of 53, and then the sub comments and sub reactions. This hopefully might be quite familiar to a lot of you. And then the other side of this is these HTTP verbs. They, in RESTful interface, they relate to particular operations on that data. So maybe it is updating something, deleting something, or actually getting something, which is kind of cool. And in a similar way to JSON and JavaScript, REST was formalized in the year 2000, but it's been like baked into the web platform ever since day one. So yeah, the very first web browser was all about kind of getting content from somewhere else and pulling it down and using HTTP. So REST is like built upon that. Yeah, I just said that. Cool. So I mean, REST is cool and stuff, but this talk is all about thinking about alternatives and challenges. So an alternative to this is gRPC. So gRPC is pretty much protocol buffers, but for interfaces. So where a protocol buffer, we use the protocol file to define how to store a particular bit of data. We write a protocol file to describe how a particular interface looks. So here we were able to define these calls, and this post comment, that comment is actually a protocol buffer. So you basically, by defining this, you're defining exactly what should be sent to an API and exactly what you're defining to come back from it. So if you've got a shared protocol buffer, you can kind of make all sorts of assumptions, and those assumptions are like bang on, which is good. Yeah, as I said, very similar to protocol buffers. Like we use the protocol compiler to generate it, and yeah, that's how it works. Architecturally, if you're used to the world of REST, there's this kind of ideology change from the idea of resources to the idea of services. So rather than thinking of kind of a big body of information that you're trying to synchronize with, you're more thinking about like services that you're trying to talk to, and they might have information attached to them, but they might not. So URL wise, this is what this looks like. So you don't really have this kind of like this data structure attached to it. You've just got a service and then a method on that. There's no use of HTTP verbs or caching or anything like that. It's just you're kind of like abstracted away from that. And when you're using gRPC, although these post requests are happening, you never know about them. You're completely abstracted away from them because the clients implement this. So you don't actually, this is just a kind of nice little detail. I really like gRPC. I really like a lot of things, but I really like gRPC. One of the things I like is in the same way as protocol buffers, instead of generating your serializers, you're generating this interface. And so you get that kind of mistake-free thing. It's mostly mistake-free. When a mistake happens, it's horrible because you have to kind of change the plugin, but it's, yeah, most of the time it's nice. I don't know why I didn't say, I don't know why, I shouldn't have said that. It's all mistake-free and it's all brilliant. So yeah, one of the things you get is this type safety, which is like, so if you're awaiting get comment, in JSON, you'd have to make assumptions of what that data was when you get it back. Whereas using gRPC, you can be completely sure that that data is going to be in a particular format. So you know that comment has a particular field in it because you've got that protocol file, which is cool. And yeah, with protocol buffers, I said you've got this kind of type safety across languages, whereas this gives you type safety between languages. So you can basically make a call from, say, Python to Rust, and you know that what comes back will have a certain type to it. We're talking about the web here, and there is a slight issue with gRPC when you're using it for the web, and that's that it doesn't work, which is unfortunate. So gRPC requires HTTP2 and some particular features of that which you don't have access to in the web because we're kind of abstracted away from this yeah, this is the kind of like low-level control. Though there are options for that. So one option is to use this kind of sub-protocol called gRPC web, and that basically works on both HTTP1 and HTTP2, and it kind of simplifies the API slightly, so you don't get all the kind of high-end stuff, but you can get a lot of the benefits. There's a couple of options for this. gRPC web proxy is like standard proxy style, like it sits in front of your thing. And there's also Envoy if you're into like kind of app meshes and microservice architectures and stuff like that, if that's your vote. Right, okay, I'm gonna do a quick demo. Right, so this demo is gonna show a gRPC service. And so that the top thing here is the front end, but also we're gonna run demo 2 backend. So then this bottom one is actually implementing a Node.js service that exports, that serves a gRPC service. So we can go back to Chrome here and go localhost 1234. Right. So when I use this echo service, I can say hello, and that is echoing back with that added emoji from that node process. So everything here is, you can't really see it here, but everything here is actually firing through that. So it's being evaluated in node, not in the browser. It's kind of hard to show. This isn't so hard to show. So basically this call allows us to access the system information. So we can pull the CPU usage information from the host machine. So you can see that, yeah, we're not really using that many CPUs at the moment. But yeah, we can basically, but what this shows is also that gRPC allows you to do streaming requests. So you can basically issue a single request and get several responses back. You can do it, you've got a few other options for that too. So we can see I've only got 63% battery, which matches here. So it's actually kind of pulling it from that host system. Screenshots, if I put capture here, it captures a screenshot. That's what I can see. And yeah, you can see as I capture lots of screenshots, you can see the CPU usage go up. So you can kind of see this all kind of hooks together. And I can change system settings in this. So this is what this kind of system service does. We're kind of exporting stuff from our local system. So that works. Cool. So received was number 3. Sorry, I'm kind of banging through this because I've got quite a lot to cover. So this received wisdom is that browsers can get data from web servers. So this is one from the very first web browser and web page. Your web browser requested content from a web server and then served it to you. And it's all about accessing content from somewhere else. But in kind of modern web, the content that we create might be created within our browser. So maybe we've got this browser over here with this blue circle and we want to get it over to this other browser. So the way that we generally do that is we have a web server that we post it through, and then the other server picks up, the other browser picks up, which is cool, it works. But we're all about alternatives today. So an alternative to this is to use WEBRTC. So the RTC is real-time communication. And the way this works is you still need a server, so you need the signaling server to coordinate the two browsers. And these two browsers connect to more servers, and these servers, these are, there's a few different servers, but basically they tell the browsers where they are in the world and how they can connect to each other. And using those other browsers, you can connect directly together here. I think Myriad, you gave a talk on this earlier this year, I think. I watched a video for that. It was cool.
Thanks.
Yeah. So yeah, I guess you can, if you want to know more information about that, check out Myriad's talk. Like it was cool. Thanks. Sorry, I forgot to ever say that to you. I really enjoyed that. Yeah. So yeah, once we've negotiated that connection between the two browsers, we can actually take all the other servers out of the picture. And then we've just got this kind of peer-to-peer connection between those browsers, and we can transfer whatever data we want between them. The data that you get, so the classic use case of WEBRTC is media streams. So this is like stuff like video and audio, like the idea that we can make like FaceTime in a web browser, which is super cool. We've also got access to data channels, which is like, a channel of data, which is kind of cool. And yeah, not used that much, which is a shame. So yeah, WebRTC data channels, love them too. They feel kind of like a WebSocket, apart from instead of talking to a web server, you're talking to another browser. What I like about them is they kind of give you an appropriate latency and bandwidth to your situation. So if me and Mike are sitting next to each other and we want to send a message to each other, like, it shouldn't take like 200 milliseconds, right? It shouldn't go to this other server somewhere else and come back. Whereas with WebRTC, that can go directly to between our devices, and it feels better, right? And I think is like, yeah, I think when people are starting using these kind of real-time features of the web, it makes things a bit more kind of like fun, right? Like it makes things interactive, and I think that's a good thing for tech. Cool. So quick summary of what I've talked about. Protocol buffers, those things that you can like store information in. gRPC, which allows you to define an interface, and WebRTC, which allows you to kind of do this peer-to-peer connections. That's basically like serialization, interface, and transport. And the reason I've kind of talked about all these three things first is that they kind of fit together quite well. So what we can do is we can take our peer-to-peer connection, we can add some gRPC semantic on top of this, so like kind of adapt that a little bit and wrap it in some special messages and call one of these a server and one of them a client. And then we can just plonk in some gRPC service stubs. And then we're cool. We've got like this peer-to-peer connection, which has all these kind of like type-safe properties of gRPC and no servers. We've taken them out the mix. What's kind of nice about this is that we're able to kind of connect lots of browsers together. So because we called one of them a server, we can connect lots of other browsers to that. And basically, if you kind of squint your eyes a little bit, what we've done is we've created a web server, but within a web browser, which is kind of, there's some cool things to happen there. So I've got a small demo of this. We don't need a backend anymore because it doesn't have a backend. So what we're going to do is run demo 3. And now what we have is we've got this web page here, and I'm going to start a Zoom service, which is using exactly the same definition as that gRPC service we used before. And now this web browser is our server. And I'm going to open up a second web browser here. And this is our client, right? So this client here is talking to this web browser server here. So I can say hello, and it comes back with something different. And it kind of looks like this is evaluating in that window itself. But actually, it's if we open up the terminal here, you should be able to see, oh, hey there. You can kind of see that it's kind of, so we're issuing commands here, it's getting evaluated on this window, and it's coming back. And it's all kind of done in a safe way. We don't have access to CPU data in a web browser, I don't think. We might do. But so these are just like random scrolling values. But I think, keep going for now. But what's nice about this is we can actually you can use that to synchronize several devices. So you can see these two browsers are synchronized by that first Chrome server thing. And we're able to kind of share stuff like that. Screenshots. This asks me if I want to use my camera on this first server window. And when I allow that, it will take a screenshot. Hello. Oh, didn't work. It doesn't work the first time, but so I can kind of do these screenshots and we get all those down there, which is kind of handy. And that works like because the browser doesn't really care where it came from. It obviously works in like Firefox as well. So yeah, that's all good. Cool stuff. Right. I'm gonna stop that and carry on here. Cool. So I've been exploring a bit of ideas with this. So that's like, that's the kind of tech part of it. But I've been exploring a few of these ideas on a kind of like a live server, which is prpc.me. And this is like, instead of gRPC, it's PRPC for peer-to-peer. It's pretty cool branding. And I'm going to show you that just now. In fact, now's the right time to do that. Right, okay, so what I'm going to do is I'm going to go to prpc.me, and I'm going to actually switch to dark mode because I like that better. And I'm going to host a new room here. So that's going to be host Bristol.js. Now, so this is our server window, like before, but we've got a public URL here, and someone's already connected to it. So what we can do is we can, nice one, Adam, you're on it. On the second window, you can see when I go to this, it's connected to a backend here. Now it's made a peer connection between these two windows, and then it's disconnected from the backend. So you can see this is now no longer online on the internet, it's only connected to this server here. And we've got 4 peer clients now. So this one, because it needs to listen for new connections, needs to continually be connected to a web server. If for some reason I refresh this page, it will reload with that same client information because it's kind of synchronized to that tab. If, however, I reload the server, you can see this is now offline. You get this kind of click to reconnect button at the bottom. Yeah, you can do that. We've got a debug page here, and you can see that this is now, you should have seen, sorry, I should have said that. Everyone should visit this URL on their phone or on their browser or whatever. That's a good thing to do. On this demo page, you can see as you pick different emoji, it's kind of synchronizing, and you should be able to see the latency of that. And bear in mind, I'm Dublin at the moment, and obviously we're doing this over Zoom as well. So this kind of like...
I was just about to say the latency on this is insane. Like literally the split second I click it, I'm getting it from the Zoom stream. Yeah, it's just like the hops that's going through is just bonkers.
Yeah, so many things about tech are utterly bonkers, right? Like I think that's the right word to say, because it's like, yeah, but yeah, this doesn't go through kind of like any intermediary servers necessarily, unless yeah. So it's basically directly to my machine. But yeah, the latency is quite low, and if you can load this site yourself and give it a bit of a shot, and yeah, you'll see it. It's even better if you're using it on the same network. Cool, right, but I'm gonna take it back there. Right, okay, cool. So, something that's kind of interesting with this is what the code looks like. So basically you define a service like we talked about before, but where this gets interesting from a front end is you can write front end components that are a client and a server. So this is in React, and I've written a kind of a client for this calculator, which is just the fields that I'd expect a client to be able to put in. And then on the server, I've put in the fields I'd expect that to have. And so it all kind of it works oddly well. And then once you've got those front end components, you can then just like hook them together. So this is kind of hooking it to this remote service rather than hooking it to, say, Redux or something like that. So it happens, there's something quite natural with taking these to the front end. And then what I think is really interesting here is when you think about what you're not doing. So we're not implementing the interface code. Like we don't really care how this value gets to the other person. And we're also not assuming any types. So we're not having to kind of be like, oh, this JSON has this particular style to it. And it's like, it feels really good. I won't bother with that. Right, okay. So onto receivables in number 4. Data should live in a data center, right? Like, so servers, we like them. Like we kind of like, when you think of data, that's where it lives, this kind of canonical place for stuff to be. So an alternative to this is to use peer-to-peer storage, or kind of like try and distribute our data across our devices. I've got a few demos for this. We're down to 3 clients. I might reload. This is super sketchy. I should have said that before. But yeah, if you go back on and reconnect, then what we're going to do is we're going to look at this this content demo. So what I can do is I can say, hello, Bristol JS. How's it going? And you should be able to see that on your devices, I guess. Cool. And also, this is just Markdown. So if we were to do Bristol, actually, yeah, I guess we can grab a picture from here. I will. Copying images sucks. Bristol. I'll look for Bristol, and we will look on Wikipedia, and we will find an image, and we will copy that image address, and we will put it in here, and we'll put in that image there, and that should upload for everyone. So what's nice about this is that when you reload your page, it reloads with that content, right? Like, so that content is persistent, but it doesn't actually, it's not persistent on a server, you know, like, so it only exists in the context of this page. And obviously this is taking that idea that the server is like the kind of like static canonical form, but we can apply the same kind of thing to more interactive data. So this is a chat server. So if I was to say hello, then you can see that kind of coming up, and basically everyone's windows kind of. Sorry, that was really badly explained. But basically, we can store these messages just within that browser itself, and just to show that we're kind of able to kind of change the processing of this. Now anything that types, anything that goes through it will be converted to uppercase. So if I say lower, yeah, so great, the feature you always wanted. And yeah, we can change it to emoji as well. And now all your letters will be converted to random emoji, which is, but what's kind of cool here, I think, is like this window has kind of replaced what kind of like server adminning is, you know, like when you've written a back end and you kind of got all these kind of nice. I'm really glad that someone did that actually. Like, yeah, thank you for trying that. That was my original thing. Sorry for anyone who missed that. Someone tried a script alert your cookies are mine, which I did think of that. So yeah, no, this basically. This is amazing. I hadn't thought of these. Anyway, but yeah, so that is dynamic data, which is kind of cool. We can also, we can go back to that at any point, but whatever. We've got access in our browsers to access more interesting data. So what this is going to do, and I'm just going to give you a bit of a warning first so that you can not do it if you don't want to. When I press the button, it's going to launch your camera in your kind of web page, and it's going to ask that first. And then when you accept it, it's going to take a picture of you and show it on this server page. So just, if you don't want that to happen, don't press anything, just leave it, and maybe cover your camera. So when I press this, you'll see PRPC wants to use your camera. When you allow, you get that video. And we can see these videos kind of coming in here. Hey, those are great. Yeah, and so basically you can see that we're able to kind of get richer data from other people. And because like this has kind of worked because we're all on laptops, if you're using phones, we could switch the camera to being the environment camera, and in that way you could kind of take a picture outwards and do stuff like that. So we've got all those kind of things to look forward to. Cool. So yeah, this is a bit of a hack and it's kind of fun. But the distributed web is more of a thing. So one of the things that is one of the projects going on is IPFS. So that's Interplanetary File System. And there's some really interesting stuff going on here. Another protocol is DAT, which allows you to kind of, it was originally kind of, I guess, like academia sharing data, but it's now kind of built into this. It's really cool protocol. Check out Beaker browser for like a native support of that protocol, and it's basically an alternative to HTTP web servers, and all the content's distributed in a cool way. It's really cool because when you're using stuff like DAT and Beaker browser, it feels kind of like we own the web again. You're like, I think there's it's kind of like GeoCities, apart from with like modern browsers. Actually, no, yeah, it's GeoCities, but like the good thing about that, which does exist. There's also this performance potential. Like, so if you're distributing your content, if you've got high volume or traffic content or like large size, then there's a potential for this kind of architecture to distribute that a lot more efficiently. So that's a kind of cool aspect. Cool. So the received wisdom number 5. So there's this idea. The received wisdoms get a bit more hazy as I go on. Sorry, this is just like interactions and focus should happen on the same device. So we got this device, and I would say interactions are like when you press it, and you're kind of, so you're interacting with it, and it's showing content back at you through the same device. I think that's just like an assumption that we've ended up making, that that's how the web should be. An alternative to this is to use multi-device interactions. So again, there's going to be a 2-second demo. We've got this, oh, not that one, this one. So if we use this, I'm going to turn timeout more. So you should be able to see that as you go on here, as you draw, we're seeing it on this main screen here. But on your device yourself, you can't actually see what other people are drawing. So we're basically, this makes a lot more sense if this other window would be on a projector or something like that. But basically, there's something interesting with like the point of interaction not necessarily being the point of seeing that content live. So here we can kind of like, if we were to try and start drawing something together, we could do that by kind of sharing the capabilities through this kind of multi-device interaction. That's super tenuous, and I'm sorry. But yeah, that's what that is. So yeah, we can kind of split our the place of focus and the place of interaction, and we can kind of mix that up a little bit and make use of other browsers. In that scenario, we've got one big screen shared amongst all of us, but each of us have our own screens that we can kind of like initiate the interaction. And I think, yeah, oh yeah, I guess Mike's demo might show that a bit later as well. There's some cool stuff with this. Like one of the things I like is, so Sidecar on iOS allows you to kind of take your tablet as a second monitor, but it also allows you to kind of make use of the fact that you can write on that. So you're kind of like combine these two interfaces in quite a neat way. An extreme example of this is a project from years and years ago called Johann Sebastian Joust. I'll plonk a video in chat later, but this is basically, you have these controllers and you have to move in a particular way in time with the music, and as the music changes, you have to kind of like you have to try and push other people over, and it's brilliant. It's like so much fun. But then what I really like about this is these two people here are basically playing a PlayStation. You know, like it's not your kind of standard interaction. So yeah, there's some interesting stuff there. And I think as devices start changing shape and changing kind of how they feel, I think it's going to become more and more important to make use of that. Yeah, I love these two. They're good. Cool. This is the last bit of wisdom, because I think I'm kind of running over time. I'm really sorry about that. And this is that browsers should provide the same features, right? Like, so we've got a phone and a web and a laptop, and there's this thing that because we're using the web, these two devices should provide the same features. And I think this is partly comes from the way that we think about user stories. Like, so we kind of, this user story sucks because it's saying, as a user, I press this button in order to do this. So this user story is basically implying an implementation. And it means that we kind of like have a button on each of these interfaces when actually one of them, it might have been better not to have it, or to have a different way of achieving that task. And I think, unlike those wisdoms at the beginning, the idea that our browsing experiences should be the same across different browsers isn't something that came from the beginning of the web. It's something that was there at the beginning. It wasn't there at the beginning, and we've kind of built it up over time. And I think it'd be good to try and get back to that. And so what I mean by this is like, so this is Sir Tim Berners-Lee with the first ever web browser that was ever created, which he wrote, which is the World Wide Web browser. And you can see it running here in the background. And what that was an amazing piece of software. And what it could do is like, it would load up a page, you could see all the content, you could scroll through it, you could kind of like do like, you could browse the web, right? And that was really cool. But there's this one thing, is like, it ran on a Next workstation. So this is like this kind of graphical UI here. And at the time, those were quite high-end machines, you know, like, so it was kind of, you had it in, like, you'd have to pay quite a lot of money, which creates this kind of barrier to using the web. So basically, someone working with him called Nicola Pello, Tim asked her to write this other browser, which was like basically the second ever web browser, and that was called Line Mode. And this browser is super cool. So like Nicola wrote this, and it allowed you to interact with a web server through a text-only interface. And not only that, like, so text-only didn't necessarily mean it on a screen then at the time. Like, you could basically browse a web with a printer and a keyboard. You know, like, it's a very kind of like different thing. And what's kind of cool about this is it broadened the accessibility of the web, right? Like, so suddenly the web went from being this thing that's like, you had to have a Next workstation, you had to have like all these kind of things compiled, to suddenly like, you need a network connection and you need some sort of computer that shows stuff, you know, like, so it broadened the scope of the web. And also it proved this kind of like browser web relationship, you know, like, so basically the web itself, like HTTP, URLs, links, that needs to stay consistent, but the browser is kind of separate from that, and it's able to kind of iterate and change and adapt to the devices. And I think, yeah, I think I really love World Wide Web, but I really properly love line mode browser. In modern browsers, we've got a bit of a different story. So we've got like tons of different capabilities that different browsers and devices might have. So some might have access to audio, video, like brilliant speech recognition systems nowadays. Augmented reality and virtual reality, GPU access, Bluetooth, all these kind of things. And this isn't so much an alternative, it's just a random idea that I came up with that I really like and it sounds cool, which is the idea of interfaces of functions. So I think this is quite a nice model for trying to support this kind of stuff. And what you kind of think of is like the features that you're serving to someone is a function of content capability and context. So for me, like, so basically this dynamic system that fulfills what you're trying to do for the user. So for content, it's like what you're actually kind of trying to get to them. So are you trying to send them a particular type of data or give them access to a particular type of task? Capabilities, like what features they have, like do they have 3D graphic rendering stuff? Do they have immersive tech, or do they have anything else? And then the context of like where the user is while they're trying to do this. Are they moving around? Are they kind of like network challenged? Like, are they offline? All this kind of stuff. And if we kind of take those three things into account and then try and think like, what is the UI that supports that best? And I think that's a kind of like a nice level to look at it. And even though I made this up and I still really dig it, it's kind of like, I think it's a really nice way of letting us make use of features. You know, like it's not that you have to support everything, it's just you need to support things in the right way. It avoids this kind of like over perfection, like trying to make everything the same on every device, like roll with it, you know, like make stuff that works well. And then I think it's good to kind of keep us on higher level goals, right? Like, so kind of thinking about what it is we're trying to achieve for the user and how we're trying to help them. Cool. So in summary, all these things. So JSON's cool, REST is cool, web servers are cool, data centers, they're cool. Interactions on the same device, that's pretty cool. And then browsers are cool. So it's all really cool. Before I go, sorry, this is like just sorry. Before I got a couple of things. This is really weird me saying it, but if you're interested, sorry, what am I trying to say? Oh God, this is terrible. Before I go, I've got a couple of things to say. Tomorrow I'm giving a talk in Milton Keynes Geek Night remotely. So if anyone's interested in this, it's going to be it's not so JavaScript-y as this, but it's going to be about like lasers and stuff. So I'm going to be talking about rendering point clouds from the sensors on our cars. So if you're interested in that, then do drop in. And then later on this week on Saturday, we mentioned this on the Zoom call earlier. We're holding this thing called Remote Hack, which is super fun, and it's a really like chill, nice event. So if anyone is interested in joining us, you'd be more than welcome. Like basically, we get together, have a chat. If you want to go off and build something or just chat about stuff, then do it. There's more information on remotehack.space. So do check that out, and if you could share it, I'd be very appreciated. So yeah, thank you very much for that. Give me a shout. We can chat later. And I'm on Twitter and I'm here. So yeah, take it easy. Thanks.